So very good afternoon to one and all present over here. I Preeti Patel on behalf of ISF College of Pharmacy Moga welcome you all in the dialogue series under the aegis of IQAC and IIC ISFCP. Dr. Satish Shilpi is the expert for the day. Dr. Satish Shilpi sir is currently working as associate professor at School of Pharmaceutical and Population Health Informatics, DIT University, Dehradun. Sir has completed his graduation, PG and PhD from Dr. Hari Singh Gaur Central University Sagar, and Sir has more than 60 research and review publications in the field of pharmaceutics, and Sir has vast academic experience. Before starting the program, I request to our director, Sir, to enlighten the program. Please, Sir. Please say a few words.
So, yes, madam. So, thank you, Dr. Preeti ji, for inviting me on this platform. So, first of all, I welcome today's expert, very dynamic, dedicated person, down to earth, and dedication toward the professor, Dr. Satish Shilpi ji. So, I welcome you, Dr. Satish ji, from bottom of my heart, from ISF College of Pharmacy as well as the IQAC. So as you know that you have already visited this institute, and I am very very thankful to the you can say you for the accepting our invitation, and we both are from the same alumni, even the coordinator, myself, and expert from the alumni of the Dr. H.S. Gore University, Sagar. So no doubt, Sagar is very well known for the academia and the research, and one of them is the Dr. Satish Silpiji among us. So I hope that today's talk it will be the very very useful to each and everyone. As you know that Dr. Satish ji, we are running this IQAC, running by the IQAC this ISF dialogue series. So purpose behind this to connect some of the peoples from academia and develop one of the you can say atmosphere of the academia and research so that we can contribute to each and other what is the need of the today to the youngster to do the work in different fields. So without taking time, I again welcome you and thankful to you for accepting our invitation. I am thankful to Dr. Preeti Patel for inviting me on this platform. Thank you very much, and over to Dr. Preeti.
Thank you, sir, for nice words. Today, sir, going to deliver lecture on high performance liquid chromatography. So I request to Dr. Satish sir, please proceed. Please, sir.
Okay. Thank you, Preeti madam. So, a very good afternoon to all. I am Dr. Satish Shilpi and would like to thanks Chairman ISF College of Pharmacy, and I would like to thank Professor G.D. Gupta sir, Director ISF College of Pharmacy, uh, and a special thanks to Dr. Balak and Dr. Preeti to give an opportunity to deliver a lecture on HPLC in this special dialogue series and ISF organized by ISF College of Pharmacy, Moga. So without any delay, I am going to start the session. Uh, Before discussing the about the HPLC, I would like to discuss some uh, instrumentation analytical techniques to quantify the drug molecule from different biological or pharmaceutical samples. So there are some techniques by which we can quantify the drug molecules from the sample. So the chromatographically we can quantify the drug molecules. So in, for example, HPLC, gas chromatography, HPTLC, and second one is the spectroscopically. So we can also determine the concentration of drug or other substance by spectroscopically. So UV spectroscopy and fluorescence microscopy, maybe spectroscopy maybe can be used for the quantification of the drug. And third one is the titration. So it is a very conventional techniques by which can use for the quantification of the drug molecules. So these are the techniques which can use to quantify the drug molecules uh, for from the different biological and pharmaceutical samples. So now come in the chromatography. Chromatography is an analytical method in which
Sir,
separation.
slides are not moving.
I think there is some technical error.
Sir,
Now it is moving.
no, sir. Sir, you can share again.
Okay. Dr. Preeti, now it is visible.
No, sir. Your whole window is visible.
This
Whole
is the screen share, so you
screen.
can first open your
You-
presentation
Yes,
and
sir.
then share it.
So now it is visible.
Yes, sir. But
So
sir, yes, sir. Now it is moving.
okay. So should I start from first, right, Dr. Preeti? Should I start from first slide?
No, sir. In continuous manner.
Okay. So now come in the chromatography. Chromatography is an analytical method in which separation of active constituent or any substance from a complex mixture is occur. It is a technique is used for separation, purification, identification of compound from a complex mixture. It consists of two phases: stationary phases and mobile phase. The stationary phase is constant phase or column packing material, and mobile phase is a movable phase. It may be solvent or mixture of solvent. So it is the techniques of the separation and can be used for the qualitative and quantitative estimation of any drug substance. So uh, now come on the next slide. It is a some discussion about the discovery of the HPLC or a chromatography. First, the Michael Toy discovered the chromatography with their experiment. Michael Toy discovered chromatography first, and they are called as a father of chromatography. They actually experimented on leaf extract, and when they filled the leaf extract in column and kept for some time, then they observed different color band on different position in the column. So that they just found the idea of the separation of different component from the complex mixture. Actually, the word chromatography come from the like chroma means is a color, and graphy means writing of pen or writing type, or just it may be drawing of the some things. So combinedly it can be say that the chromatography. So first they separate the leaf of extract of the leaf in the column. After that, uh, there different modification arise and created in the development of the development process of the chromatography. And in 1970s, the high performance liquid chromatography was developed. In this slide, I want to show that the separation or partly separation technique of separation of the molecules from the complex mixture. So actually, the molecules just partitioning in two phases, like stationary phase and mobile phase. Actually, the molecules, if the solute molecule have high affinity and affinity for the stationary phase than the mobile phase, so it will retain on the stationary phase for long time, and the retention time and retention factor will be actually more. So suppose any molecule retain for more time, so at the stationary phase, so it will retain and the time of the separation will very long actually for this particular compound. And the molecules which is easily move uh, from the stationary phase, actually the stationary phase, mobile molecules which is not have good affinity to the stationary phase, it move very fast from the uh, column with the mobile phase. So it will not retain actually in the stationary phase, and separation from the mixture is occur. So we can say that the affinity of the solute to the mobile phase is very low in comparison to stationary phase. Then solute will move with the mobile phase very fast. That means the retention time will be very low. And in case of so this is uh, the technique, process which is happened in the during the separation of the molecules from the chromatographic column.
Sir, I think again slides are not moving.
Okay.
It is on the
I
drug
think some
quantification.
network issue. I think it is.
Maybe, sir, due to net
Maybe it
problem.
is a network problem. So
Yes,
that's
sir.
why it is.
No problem, sir.
Now it is visible or not?
Sir, it is visible, but the second slide is method of drug quantification and analysis. This slide on the front page.
Again, I should stop the sharing and then again share the
Yes,
slide.
sir. Yes.
Only second slide visible now.
Yes, sir. Second slide is there.
Actually, heavy running is now occur in my place. So I think they may interfere the network.
Yes, sir. Now it is moving. History, sir. History part.
History.
Yes, sir.
Okay. Now it
Yes,
is
sir.
partly.
Yes, sir. Yes.
Difficult, you can change your slide through the keyboard or mouse.
Sir, keyboard.
Keyboard. So you can change another slide.
Uh,
That's okay. Now, okay. Yes, continue, Silpiji.
Okay, sir. Thank you, sir. Now, common the HPLC principle. So, high performance liquid chromatography involves the injection of a small volume of liquid sample into a tube packed with tiny particles. Maybe it may be 3 to 5 micron in diameter, which is called as stationary phase, where the individual component of the sample are moved down the packed in the packed tube with a liquid, which is called mobile phase, which is forced through a column by a high pressure delivered through a pump. Actually, जो mobile phase which is pumped through a column, it's uh, have some high pressure. It actually move from the column with high pressure, which is developed by the pump. So the column packing is used to separate the component from one another. It involves various chemical or physical interaction between their molecules and the packing particles. The separated components are then detected at the exit of the column by detector that measures their amount, and the output from this detector is called liquid chromatogram. In this place, actually, the column packing is responsible to separate the component from each other. It involves, the separation of molecule based on their affinity to bind or interact with stationary phase. The molecule can bind with or interact with low, moderate, and high affinity, and based on the affinity to bind the stationary phase, the molecule move uh, very slow, moderate, and accordingly. The molecule have which molecule have a high affinity to the stationary phase, then it retain for a long time, and molecule which is a low affinity to stationary phase, which move very slowly. Sorry, it be I'm wrong that I'm saying if the affinity of the molecule have uh, affinity of the molecule have very high with stationary phase, so it will move very slowly, and the affinity of the molecule with stationary phase is very low, then it will move very fast from the column. In we can say that we can see that the diagram in the slide. So in the first step we should inject the sample from in the column, and with the mobile phase. So the sample contains some mixture of the compounds or drug molecules, so it will move from the mobile phase in the column, and the on the basis of affinity of the molecule in this with the stationary phase, it will separate from different in the column in the different point in the column. So after that, suppose any molecule come from the exit from the column and just come in the detector, so it will detect by the detector, and the detector will just send the information to the computer system, which present the data in the in the form of chromatogram. So we can say that see the chromatogram here. So this type of the chromatogram will just developed by the computer system, and there are so many peaks are we can say see that in the slides in the program. So every peak represent a any particular molecules. So it is the based on the area of the peak, we can say that it is directly represent the concentration of the drug. Suppose any molecule have high area peak, so it may say that the concentration of the drug or molecule is high. So this is the chromatogram. Now come in the application part of the HPLC. So HPLC can be used for the separation of amino acid, proteins, carbohydrates, and it may also used for the analysis of drug, hormones, vitamins, etc., and help for qualitative and quantitative analysis of complex mixture. In case of in the field of pharmaceutical and biopharmaceutical, the HPLC can be used for the quality control of the pharmaceutical product, for the determination of shelf life of the pharmaceutical product, and the separation of complex mixture we can use the HPLC for the to determine the pollutant in the environment, or in the may it may be determined in the some water drain water, or any places where the water is filled in, like a sea, or we can uh, determine the concentration or some insecticides or pesticides in water which is filled in different places of different area. So, and clinically we can use the SPLC as for the determination of antibiotics. We can determine the sub blood components, and it is used for the quality to maintain the quality of food and flavor. And we can measure the sugar and different juices of the marketed product. We can also ensure the soft drink consistency and quality. So these are the application uh, in different field where we can use the HPLC for the quantification of the different type of component. These are the some pics of the HPLC instrumentation. Now come in the types of HPLC operation. So it may be uh, normal phase, it may be reverse phase, it may be adsorption, it may be ion chromatography, it may be exclusion chromatography. In case of normal phase HPLC, they are also known as normal phase or absorption chromatography. This method separate analytes based on polarity. In normal phase HPLC, the polar stationary phase and non-polar mobile phase generally use in this chromatography type. Therefore, the stationary phase is usually silica, and typical mobile phase are hexane, methyl chloride, chloroform, methyl ether, or and maybe other type of mixture of the these type of solvent. The techniques is used for the water sensitive compounds, geometric isomers, cis trans isomers, class separation, and chiral compounds. In case of reverse phase HPLC, the stationary phase is non-polar. In case of normal phase HPLC, the stationary phase generally uh, polar in nature, but in case of reverse phase HPLC, it may be it will be non-polar in nature. Will the mobile phase is an aqueous phase type of we can use in the reverse phase HPLC, and it may be moderate polar. We can say that it is a semi-polar solvent in we can use in the reverse phase HPLC. It work on the principle of hydrophobic interaction, and the more non-polar the material, and the longer it will be retained. This technique used for the non-polar, polar, ionizable, and ionic molecules. In case of exclusion SPLG, it is also known as gel permeation chromatography or gel filtration chromatography. The column is filled with a material having precisely controlled pore size, and the particles are separated according to their molecular size. Larger molecules are rapidly passed through the column because it is not retained by the uh, packed material, and a small molecule penetrate the porous packing material particles and elute later. In case of ion exchange HPLC, in this type of chromatography, the retention is based on the attraction between solute ion and charged sites, which is bound to the stationary phase. Some charge ions are excluded, same charge ions are excluded very rapidly from the column, because it will not retain by the column stationary phase, because it is if any molecule have similar charge, so it will move from the column very fast. The technique is used in purifying water, analysis of ligands, proteins, carbohydrates, and oligosaccharides. In case of bioaffinity of SPLC, In this type of chromatography, separation is based on the reversible interaction of protein with ligands. Now coming the instrumentation of HPLC. HPLC instrument generally consists of mobile phase reservoir, HPLC pump, sample reservoir, sample injector, HPLC column. It may be connected with a pre-column with man column, which is also called guard column, or we can say that pre-column or post-column. It may be called as guard column. So, and after that, the detector, it may be UV, PDA, mass, and other detector may be just connected with the HPLC system. Then based solvent container and data collector. And very briefly, we can explain the instrumentation of HPLC. Uh, in this slide, we can see that first, in this point, the solvent and mobile phase reservoir. So it is a reservoir for the solvent or solvent mixture, which is which will actually generally used for the as a mobile phase. So the reservoir made of glass or stainless steel, and it have capacity to hold 1 liter of mobile phase, or uh, the condition or the characteristic of the reservoir is, is that it should be inert. The stainless steel should be avoided for use with solvent containing halide ion. We just keep in mind during the use of halide ion content solvent. So at that time, we should avoid the stainless steel container, because the halide ion will just uh, make corrosion with stainless steel container. So it may be block the uh, column, or it may damage the HPLC system. After that, a degassing filtration of mobile phase system is inbuilt in the HPLC system. So it will actually use for the degassing the solvent, because there is it may be chances of some involvement of gases in the form of just bonded molecules of gases in the different solvent molecules. So it should be avoided before passing the mobile phase in from the HPLC column. So mobile phase are degassed or stirred by string, or by string of the mobile phase by the use of tactics of vacuum, or maybe sonicate, or may be replaced by the inert gases like helium or other gases, inert gases we can use for the degassing the solvent system. And vacuum degassing system is very actually not very efficient, but it is used for the degassing in many places. But the sonication process, or the degassing by the inert helium gas, is very significant or very efficient techniques to degassing the solvent system. After that, the pump system is inbuilt in the HPLC instrumentation. The solvent or mobile phase must be passed through a column at high pressure at up to 6,000 psi. As the particle size of the stationary phase is smaller, as 5 to 10 micrometer, the resistance to the flow of the solvent will be high. Hence, high pressure is recommended. So, high efficient pump will be connected with the HPLC system to flow the mobile phase constantly and very efficiently through the HPLC column. So there are so many type of pump which is inbuilt with the HPLC and work very efficiently. We can discuss it pump later. After that, the sample injector system are inbuilt uh, before the column main column system. So sample injector device may be manual or it may be automatic, uh, and it may be, for example, septum injector, stop flow injector, and Riodine injector may be used for the uh, in the HPLC system. After that, a column system is come, and before analytical column or main column, a pre-column or maybe it may be called as guard column may be connected with the in this SPLC system. It is mainly used to remove the impurities from the solvent and thus prevent the contamination of the analytical column. That's why we can call it as a guard column because it remove all the impurity or particular matter if any which is present in the solvent system. So it is a used as a guard of the main column. After that, the main column is connected. It is a main functional unit of the HPLC system. The actual separation is carried out here. It is made of stainless steel tube. Length may be vary from 25 to 100 centimeter, and the internal diameter may be vary from 2 to 4.6 millimeter, and the column is filled with small particle. Maybe it may be 3 to 10 micron, or maybe more or less, and the based on the different efficient uh, what we achieved uh, for the analysis. The solid support can be silica gel or aluminum, and may be other type of material which is invented recently. I will discuss some um, supporting material or stationary phase material after some slides. After analytical column, the detector may be attached with the HPLC system. It may be UV visible or PDA detector. It may be fluorescence. It may be conductivity detector. It may be light scattering detector. It may be mass spectroscopy, spectrophotometry will be attached with the as a detector in the HPLC system. After that, the a waste solvent reservoir may be is connected with the SPLC system, and after the tractor, a computer system uh, is attached with the HPLC system to just represent the chromatogram or separation process in the form of chromatogram. So this is the instrumentation, all of the instrumentation system in the hello, hello. अभी आपने रोका हुआ है क्या? नहीं, अभी 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 आपने रोका है क्या इसको? ठीक है. So these are the some HPLC column which is we can see in this slide. It may be vary according to use of analytical process. I will take only 5 minutes to compile my presentation. So this is the HPLC stationary phases which is used for the HPLC packing of the HPLC column. Uh, First is the fully porous silica particles. Second one is the fused core superficially porous silica particles. Third one is the monolithic silica. Fourth one is the fully porous polymeric particles. And fifth one is the fully porous carbon particles. It may be used for the packing of the stationary phase. Uh, I want to show some influence of particle size which is packed in the column. So they are the effect of particles on the efficiency of separation or efficiency of the analysis. The number of theoretical plate will be increased with decrease in the particle size of the packed material. The time will be reduced for analysis. It may be actually if we decrease the size of the particle size which is packed in the column, so it may reduce the time of this analysis and also reduce the size of the column. As we use the decrease the number size of the particle of the packed material, so number of theoretical plate will increase in particular time, so it may increase the efficiency of the separation. Similar, it will represent in uh, uh, the, the separation based on the particle size which is used in the packed column. This is the influence of flow rate. If we increase the flow rate of the solvent, then the retention time will be less and take very less time to analysis. This is the effect of packed particle bed in HPLC column. If we use fully porous particle which shows poorly ordered HPLC packed bed in the column, which is responsible for broad peak due to the eddy diffusion. And when we use fused core particle which shows highly ordered packed bed which give sharp peak due to the absence of eddy diffusion or any eddy diffusion of the solvent. This is the effect of it's packed type of material. Now the selection of why how we select the and which type of the column we should select for the different type of the material. So we can select C8 and C18 column for different uh, hydrophobicity material, and we can use C30 HPLC column for geometric and positional isomers separation, and for the component which contain many hydroxy group, so we can use reverse phase amide column, and F5 column we can use for the aromatic bases, and F5PFP and phenyl hexyl and biphenyl type of the column used for the some aromatic compounds, and the compound very polar in nature, so we can use HIL, IC base, GIC, and HIL, IC, and supel carbon chiral stationary phase. So there are so many matters are there to present, but uh, if we if I get a chance to show my slide, then I will show it in next presentation. Thank you, Dr. Preeti, and thank you, sir, to give the opportunity to present my uh, lecture in this series.
Thank you so much, sir, for this wonderful lecture. Uh, we are grateful to you for accepting our invitation in very short duration. and we are thankful for sharing your knowledge and experience with this ISFCP dialogue series. Thank you so much, sir. I over to you, Director sir.
Thank you very much, Dr. Preeti ji. So, thank you, Dr. Satish Shilpi ji. You have given the excellent informations, basics, what is the utility application of the HPLC. Nowadays, most of the researcher, those who are the dependent on the UV spectrophotometer. So now this is the recent advancement in the even in the pharmaceutics. People say they are the more precision and they want to the study up to the nano form. So obviously it's the need the excellent technique for the HPLC, and most of the institute they are the providing the opportunity to faculty member as well as student to do the work on the HPLC. So thank you very much for the nice information, and technically you have given each and every part you have completed, including the what is the need of the you can say application as well as what is the specification of the instrument parts and their technology. You have explained in the very simple manner, as well as how to we can utilize it. So thanks to you for accepting our invitation and grace the function and deliver a very important talk. Thank you, Dr. Preeti ji, for coordinating of this session, and
Thank
thanks to the ISF College of Pharmacy and Dialogue Series to provide the opportunity to interact such types of the experts, and this types of the talk will be the useful professionally to each and every pharmacist or the professional those who are related or working on HPTLC. Thank you very much.
Thank you, sir.
thank you, sir.
Thank you, sir.